faculty in Computer Science Department, and I'm also the project director of I Have Drishti, which is a technology and innovation hub on computer vision AR VR. Today, I would like to extend a very warm welcome to our guest, Professor Govind Raju. It is our privilege that he's here. He agreed to come, and literally in the afternoon, he was telling that you guys are giving me a very warm welcome. So in a true sense. He's one of the most renowned scientists and the Vice President of Research at UB, at University of Buffalo. And he has kindly agreed to give deliver an institute lecture on AI for social good. So first I would like to request our director, Professor Shantanu Chaudhary, to extend a floral felicitation to Professor Govind Raju. Dr. Chaudhary and Dr. Venu, please come on stage. I would now like to request Professor Chaudhary to give the welcome address.
Thank you, Mayank. Let me welcome Venu to IIT Jodhpur. And it's a great occasion for IIT Jodhpur to have Venu delivering institute lecture. And as Mayank has stated, he's one of the most distinguished researchers in this area of, broadly the area of pattern recognition, starting from document image analysis to biometrics, security, and all this space, he has made very significant contributions. And as a person also, he's unparalleled, and I know him for years altogether. And it's really a lovely occasion for me to welcome him to IIT Jodhpur. I'm absolutely confident that we shall have a fantastic lecture and which will open up not just the technical perspectives, but also a kind of a vision about AI for social good. And AI for social good is not just something to be on paper, but it has to get translated to practice. And I think we are all looking forward to that inspiration, that motivation, and that background. And listening from a distinguished faculty who has been at the forefront in this research, I think it will be a great occasion and opportunity for our young students and also young faculty. So, let's look forward to exciting few hours in this evening. Thank you.
Thank you, Dr. Chaudhary. Professor Govind Raju is the Vice President of Research and Economic Development at the University of Buffalo, the State University of New York. He is responsible for managing the university's research enterprise, university-industry relationship, and economic development. The university's research contribution to the economic and cultural vitality of New York State and around the world by discovering knowledge that helps resolve global challenges. Professor Govind Raju is a SUNY distinguished professor and a leading authority in the area of pattern recognition and machine learning. He founded and led a successful multidisciplinary research center for Biometrics and Sensors, which is internationally recognized as one of the top research labs in the field of, in this particular field. In fact, when I was looking for my PhD position, I applied to his lab, but later on I joined at West Virginia. He is the recipient of 8 Best Paper Awards and has co-authored 6 books, and over 450 refereed publications with over 16,000 citations. He has served on the editorial board of several premier journals, and he has been the principal investigator on continuous sponsored funding of nearly $70 million over his careers. He has served as the major supervisor of 44 doctoral students and mentored over 100 graduate students. Professor Govind Raju is a fellow of IEEE, ACM, IAPR, NAI, and SPI. He is the winner of IEEE Technical Achievement Award from the Computer Society and IGDAR Lifetime Outstanding Achievement Award from IAPR. On a personal front, I have worked with Dr. Venu for a very long time. Dr. Venu, jointly with a few other leading researchers in biometrics area, they started a conference named as IEEE Conference on Biometrics Theory, Applications and Systems, BTAS, in 2007, which is right now considered as one of the established venue, very premier venue for the area of biometrics and known as International Joint Conference on Biometrics. In the very first edition of conference in 2007, my work was judged as the Best Research Award, and I had the honor to receive the award from Dr. Venu and Dr. Boyd. Later on, I worked with Dr. Venu as the Associate Editor of IEEE Biometric Compendium, where he was the Editor-in-Chief. In 2015 and 16, when he was the President of IEEE Biometric Council, I was his Vice President Publications. And we started the concept of IEEE transactions on biometrics, which later on saw the light, and it was inaugurated in 2019. So he has been a great mentor for myself, and he has been very kind to support throughout. Thank you, Dr. Venu, for all your support. So now I would like to invite Dr. Venu to deliver his institution seminar on AI for social good.
All right, good afternoon, everyone. As has already been mentioned, thank you to all of you for the really warm welcome, the generous introduction, warm in more ways than one. I am told the temperatures are today above 40, so it's nice. Okay, so today's topic, and you must have seen this, I have seen many workshops being held under the name AI for social good. And I thought today I'll share my own perspective on this topic. So when we talk about AI for social good, let's just dissect the title itself and go part by part and see what exactly AI is, what is artificial and what is natural in intelligence, and why are certain applications or certain projects considered as those being for social good and not others. Because end of the day, we are all working towards the good and betterment of society, but I'll make that subtle distinction. So let me, before I get started here, I thought I will share a picture. Oops, sorry. I don't know why. It's not moving. It's not moving. Yeah, also. Just use this. The long one or that one. I thought I'll share a nice picture of our campus during summertime. This is University at Buffalo, and I'm very happy that Director Shantanu Chaudhary will be visiting us in a few weeks, and I welcome anybody who is interested in collaboration and partnerships, and including our friend Mayank over here to visit our campus. It's a really nice place to be in summer. So winter in Jodhpur and summer in Buffalo, you have it all set. I also thought, just to give you a sense for our university and how we conduct research, and tell you a little bit more about University at Buffalo. So it's part of the State University of New York system. So the State University of New York system is the largest university system in the world, and it has 64 campuses. Of these 64 campuses, there are 4 campuses which are considered as research centers. So it's Buffalo, Stony Brook, Albany, and Binghamton. And Buffalo is the flagship campus of the State University of New York. It is the most comprehensive of the campuses. And it's also part of the elite AAU group, American Association of Universities. There are 65 universities in this elite club. And the way you get membership into this club is based on the volume of research that is conducted during the year. So an NSF, National Science Foundation, tracks the volume of research. So at UB, it is somewhere in the neighborhood of $425 million a year. And this is important, of course, to talk about, how we are improving, people's lives by conducting research and also training our students. A research university has the advantage that when the faculty are teaching, they are not giving just the solutions to problems, but are actually teaching them how to solve problems. So that's the difference between a research faculty and a faculty which is purely, teaching alone. So the university's funding, so research is a big part, and the university collects overheads, when different agencies, whether it's National Institute of Health, National Science Foundation, when they give grants, there is an overhead, and most US universities have an overhead of about 60%, somewhere in the range of 55 to 75%, which means at UB, a third of the project's cost is taken as overheads. And so the funding model for the top universities is you get state appropriation if you're a public university. If you're a private school, there is a foundation endowment. And then there is the overheads collected, there is philanthropy, and then there is commercialization of technology developed and so on. So there are multiple sources of revenues that come in, to run the university. So when I talk about the AAU, a significant portion of the university's budget is driven by the research enterprise. And my office, essentially, so the Vice President of Research Office, oversees research, across the campus in all disciplines. So whether it's medicine, engineering, computer science, humanities, and so forth. We have about 30,000 students at University at Buffalo. It's like the largest campus in the State University of New York system. About 10,000 graduate and about 20,000 undergraduate students. A large percentage of our student population is international, 16%. It's one of the higher percentages when it comes to US universities. And as I mentioned already, it is comprehensive in that we have the School of Medicine, Business, Pharmacy, Law School, Engineering, Social Work, Nursing, and so on. So it covers the entire gamut. Okay, so with that quick background about my university, let me just move on to the topic for today, which is AI for social good. I thought just to get us started, it will be nice to share with you the history of artificial intelligence. And I'm sure you must have seen charts like these in various forums. This one has been created by myself. And so this is my perspective on what are the landmark or the milestones over the last 70 or so years which has brought us to where we stand today. So in 1950, Turing, he came up with what is called the imitation game and the Turing test. And Turing is considered the father of computer science. The biggest award in computer science is named after Alan Turing. In 1955, McCarthy in Berkeley, University of California, Berkeley, actually coined the term artificial intelligence. And this was part of a proposal that was submitted to a federal agency. And that's how the name gets its origins. In 1957, for the first time, they talked about how you can automatically prove theorems, right? So I remember from high school, when you do trigonometry, everything is about proving and coming back to QED. So left hand side, right hand side, and how do you show that certain things are equal and so on. So he came up with method of proving theorems automatically. In 1957, Rosenblatt, came up with the first two-layer artificial neural network called the perceptron. In 1972 at Stanford University, they came up with the first expert system. This was essentially a bunch of if-then-else rules. If this happens and then this happens, else something else happens. So you have a whole bunch of rules, and coding that, came up with the first expert system. Was called Mycin. It was in the health domain. And then they had what was called the winter of artificial intelligence. So there was this initial surge of excitement about coming up with machines which could think and have that intelligence component. But progress was less than what was projected. And so that period was called winter of artificial intelligence, implying that if you were writing proposals to federal agencies, and if the keyword artificial intelligence was there, you won't get funded, because they didn't believe it had any future. And so Shank and Minsky, they talk about artificial intelligence. And then in 1986 or thereabouts, just when I was graduating from IIT Kharagpur, so co-alumni with your director in Kharagpur. So Romal Hart and McClelland came up with artificial neural networks and backpropagation. And that was considered quite revolutionary, and probably laid the foundations at that time, which will bear fruits some 30 odd years later. So that foundation was laid in 86. And then in 88, Pearl came up with Bayesian networks and reasoning, and he also recently received the Turing Award. Then in 97, I would say the mid-90s were, very critical, in laying again, the basic foundation for launching artificial intelligence. IBM came up with what was called the Deep Blue, so they were looking for a chess playing program which could beat the top grandmasters. So a machine can beat chess, and as you know, growing up, if somebody was good in chess, they said that guy has lots of brains, right? Because chess is a game of thinking. So that was accomplished in 1997. And what is very relatively less known fact, other than those who have been in association with Buffalo and have been in the document analysis community or pattern recognition community, what is less known is that around the same time at University at Buffalo, there was a success story that was being architected. And yours truly, was part of that project. And I will describe that in a little more detail in the subsequent view graphs. But that is about the same time when the Deep Blue was going to beat the top grandmasters. In 2004, for the first time, DARPA, which is the Defense Research Project Agency in the US, came up with a project for autonomous vehicles. Okay, so they came up with a challenge for different groups. They would go to the Arizona desert and they have to develop the vehicles which would drive autonomously and would navigate and steer and so on. And that once again has been probably a lot of hype, but has been the trademark of the revival or the rejuvenation of artificial intelligence. In 2006, Hinton came up with the deep networks and deep learning, and I was just informed by Mayank that his citations are probably one of the highest in the world. Then in 2007, Fei-Fei Li actually came up with ImageNet. And so essentially, once we had lots of sensors, all these cameras taking pictures everywhere, and storage became cheap, that you were able to collect data sets of very large magnitude, which was not possible before. And that also has a very significant role to play in where artificial intelligence is today. In 2009, Andrew Ng, talked about large-scale unsupervised learning with GPUs. And then in 2011, we know there was a Jeopardy. Jeopardy is a game, it's like a quiz game, right? So they had a computer, and you had all the quiz masters, and the machine, which is called Watson, could beat any human being when it came to answering general knowledge questions. So that essentially is one view of looking at the milestones in artificial intelligence. And as I said, 1997, I believe, had a critical role to play. So when we talk about artificial intelligence, it's essentially the intelligence of a machine. So it begs the question of, if that is machine intelligence, then what is human intelligence, and how do they relate, and what is the comparison and contrast between the two? So let me give you a brief summary of the machine learning success story, which, by the way, in those days was not touted as an artificial intelligence project, because, as I said, artificial intelligence was not as the most desirable topic when students came to labs and they wanted to pick up things to do for their thesis. They were encouraged to do operating systems or databases, compilers, and languages and other things, because artificial intelligence at that time was supposed to be only for toy problems. You move a block from here to there, put one block on top of another. Those are the kinds of projects they were looking at. So we essentially talked about document analysis and pattern recognition. But looking back, I'm sure you will agree that this was one of the first success stories in artificial intelligence. So what was the idea? The idea was that if you have an envelope and you have an address written on the envelope, can a machine take a picture, an image of the address, and figure out where that mail piece must be sent? So the idea is, somebody writes the address on an envelope, puts it into the mailbox. No human being ever reads that address. A machine scans it, processes it, decides what the destination is, and generates a corresponding barcode. It slaps it onto the mail piece, the barcode gets sorted, and the mail piece goes to its destination. You and I will agree that that is intelligence, right? Somebody wrote something and a machine read it. And what we had going for us in that project was, while people can write sloppily, they can have handwriting which is very poor, it's always the case that the intent of the person writing is that that particular mail piece should be delivered somewhere, right? So the intent is there, and to capture that intent is the job of the machine. Now keep in mind, it is not just faithful reading of the address, because if a human being made a mistake, let's say the PIN code was incorrect or the city spelling was incorrect, you still expect, the expectation is still that the mail piece should be delivered, right? So the machine should not just reproduce the incorrect spellings or the PIN codes, it should do the corrections and capture the intent of the writer. And that's what we were doing. And this story of success is that, so about 25 years back, we accomplished this for the first time, where 0% of handwritten addresses were read by a machine. We took it in our lab to 20%, then 40%, then 60%. And today, more than 98% of all mail pieces, whether handwritten or machine typed addresses, are completely read by a program. No human being takes a look at it, okay? And when the machine gives an answer, it is 98, 99% correct. It rarely makes a mistake, okay? which is essentially what the human recognition rate is also. So this is a remarkable accomplishment, and we were able to do this in real time in the field, not just in the lab. We took it then to Australia Post, we took it to UK Royal Mail, Canada Post. They all used our algorithms. And I was just talking to Mayank about technology transfer and industry relationships. These were the days where people were not expecting us to solve this problem at all. The federal agency was giving us millions of dollars to work on this problem, but not everybody believed that this could actually be done. This is very much like the UAID project, where in the initial days we surprised ourselves that you can have more than 1 billion people take fingerprints and iris taken and then recognition happening. So it was a story like that. I remember and this was a group of graduate students, by the way, for all the students in the audience. A group of graduate students and some research scientists like myself, we worked on this and we actually put it in the field. And we were like this, the first time it was deployed, we weren't sure. First, we weren't sure that the system won't crash, okay, that this is code written by our students. The system ran perfectly and was able to save hundreds of millions of dollars for the Postal Service. Because the volume of mail in the US is so large, it's about 500 million pieces a day. And about 15%, 10 to 15% of that is handwritten. So you can imagine about 40-50 million pieces of mail are going through the system every day. And if you can read that automatically, you can save millions and millions of dollars in terms of actual manual, keying in. So again, the reason I'm mentioning this is I want you to see and draw the contrast with what today is called artificial intelligence and how we approached these problems in those years. So let me just play a brief video. This was prepared, I think, by Siemens, and just to give you a dramatic effect of the project.
Letters then enter the Advanced Facer Canceller System. This machine uses specialized cameras to take pictures of envelopes as they speed by. These pictures are used by the computer to find the stamp, locate the address, read the handwriting, and compare the address against a database of known addresses.
So that is just a short video clip. And now let me, show you why this was intelligence. So in those days, we would look at the images of cities, handwritten cities, and if I asked you, to tell me which city in the United States is the profile that I show you over here, I don't know if some of you can guess. Now, if I actually gave you some choices, which one do you think it is? I hear Buffalo, right? So you can see that once you are given choices, then although you cannot read, all the letters of that word, based on the choices, you say, well, it cannot be Amherst because there is no descenders in Amherst. When you have a handwritten Amherst, no letter is coming down, the middle zone. It cannot be Boston for that same reason. So it's probably Buffalo because I also see some ascenders, one next to the other. And this is like, when we give our competitive exams, as long as you have a general idea of what the answer is going to be, and you can use some clever elimination, you can arrive at the right answer. So lots of students want multiple choice questions, right? Because they can do a lot of guesswork. And as in all multiple choice questions, once you have none of the above, then you scratch your head because you're not very sure whether it is the answer or not. And that's the kind of reasoning we implemented in our postal address recognition system. So what we were able to do is we were able to find the profiles of different words We would look at, roughly where are the ascenders, where are the descenders, where are they positioned in the word, and we will look at a list of choices, and that's critical. Without the list of choices, given 40, 50,000 cities in the US, it won't be possible for you to tell me the answer. But if I gave you a short list of choices, you can do, the process of elimination and verification and arrive at the right answer. And so this intelligence of being able to eliminate from multiple choices is what we captured in our algorithms. And this is just one example, but I thought I'll give you that flavor, which was actually published in PAMI in those days. Now, just trying to close the loop, with the addresses. So what we do is, if I have a handwritten address as shown, we will first look at the pin code or the zip code. And since you have numerals, you have 0 to 9, that is 10 classes. So you solve the 10 class problem, you figure out what the zip code is, you do the same thing with the street number. So you have to automatically locate based on general address writing trends that zip code would be on the right and the bottom. This is where somewhere the street number would be. You decide that this is a numeral and not alpha text. So once you have the zip code and the street number, you go and look up the postal directory. Now in the US, there are more than 250 million destination points possible, okay, all the addresses. So that means this is, to start with, a pattern recognition problem of 250 million classes. There is an image, which of those 250 million is it? So once you have got the zip code and the street number, and you look up the postal directory, and this is the power of context, you realize that in most cases there are only about 50 or 20, somewhere in that range, street names that are possible. There are only that many streets in that zip code with that street number. And so you have a list, and now it becomes your multiple choice question. You have 15 or 20 choices, you have extracted the snippet of the street name, and then you do that rough matching and process of elimination and verification, and you decide that what is written over there is Livingston Street. So there is a code, a 4-digit code which goes with that particular street number. You slap it to the 5-digit zip code, you get the 9 digits, an additional 2 digits which are the last 2 digits of the street number, and you have 11-digit unique barcode which actually gives you the destination address. And also the power of context is such that in lots of cases there is actually only 1 or 2 street names possible, so there are only 2 choices. So in order to do recognition, all that you need to do is even just the length of the word. You look at the choices, one word has 3 letters or 4 letters, the other one has 10. Just by looking at the size, you can say what the answer is. And so this is the kind of intelligence, we were able to build in the address recognition system. And I'm sure you will agree that this is a really neat machine learning success story. Then we took this idea and we went, wherever handwriting recognition, so bank check recognition. Here is an example that I'm showing you of medical prescriptions, right? So the doctor, not today with smartphones, but those days could fax the prescription automatically read. And how do you read automatically? Well, we all know what doctor's handwriting can be like, right? So because we have the patient's history, we know what ailments are there, what possible medicines can be there. Again, you have a short list of choices and you can do the recognition. And as you can see, even for humans, if I don't give you the context, it won't be easy to read what those medicines names are, but we were able to do that. So that gives you a sense for how we started with pattern recognition and the kind of intelligence, and this is very different from what you do today with lots of data and you have the CNNs and your deep learning and so it's a totally different approach to artificial intelligence. For some people, probably more satisfying because it kind of follows how humans think. right? Like in the multiple choice question. It gives you a more satisfying way of looking at these algorithms. So a rough, and this is general terminology, we say that initially it was all artificial intelligence, and then it kind of evolved into some models, and we call it machine learning. So in the initial stages, it was very, very human-like, and like an expert system kind of rules-based. And then today it is mostly deep learning, where there is learning from lots and lots and lots of examples. And again, you know that's not what humans do, right? A human being can see one cat and recognize all the cats, whereas a machine would need to see all types of cats ever created, in order to recognize them. And so once again, a contrast in intelligence. So what exactly is the difference? When we talk about machine intelligence and human intelligence, in fact, Alan Turing, who, as I said in 1950, framed the question, can machines think? And the Turing test, comes from there, where for those of you who are probably not familiar, the Turing test simply says that as long as the machine in a question answer scenario cannot be distinguished from the human but just based on the responses. So you have A and B, so A is the machine and B is, let's say, the human, and C is the judge, okay, and there is a screen in the middle, so you cannot actually see which side is the machine and which side is the human. So you ask questions and you get responses, and based on that, if the machine can give you responses which the person C, believes is human, then you are supposed to have intelligence. So this was the Turing test. Then what is human intelligence? What is being human mean? So we talk about animals can also eat, sleep, and procreate. So what is so special about human intelligence? Well, they can use tools. They know how to use the wheel, the fire, technology. But what really makes us human? And I'm pointing this out just to talk about artificial versus human intelligence. Well, some people might say that humans use language, there is a bonding that happens, there is emotions, but it is not very clear that animals don't have some of these same qualities. There's a culture, morality, and philosophers will talk about consciousness and so on. But one way of putting this down is, human intelligence, I would say that a human being is intelligent if the person can read and write. Okay, so in artificial intelligence, you have OCR algorithms and text recognition systems. Humans will be called intelligent if they can listen to something and comprehend and respond. You can have speech recognition and NLP in AI. Similarly, you can solve math questions, describe pictures. All these we consider as intelligent human activity. And there is actually a corresponding artificial intelligence domain, subdiscipline, which tackles these problems and which can emulate that same human intelligence. Of course, a few years back, we would have said, well, machines, they can't have emotions. They can't write poetry, for example. They can't paint, so humans are different. But, things are changing, right? So here's an example that was presented in New York Times, by the way, about 7 years back. And the question was, it's like a quiz to its readers. It said, can you please tell which of these passages were written by humans and which by machine? So I'll just give you just a few seconds to look at these, and you can tell me which of these four was written by a human being. Any guesses? The fourth one is by a human being. Okay, so here is the key to the quiz. All 4 are written by a machine. None of them have been written by a human being. In fact, the right side bottom is a novel, True Love, written like a Russian novel by a machine. And so all of them are actually machine generated. So that is quite a startling revelation for many of us. In fact, if you go to the newspapers, many of the weather columns and the finance columns are all generated from templates by machines. Okay, so the template like a shallow magnitude 4.7 earthquake was reported. This is all machine generated, you know. So you cannot just say that humans alone can do poetry. And now, since I have already made such a big deal about this, you can also tell that both these paintings were made by a machine. This would have been unthinkable a few years back, right? So while the line is getting blurred, you know, we still struggle to say what it is that is truly exclusive for human intelligence. Because if you only look at input-output, like Turing set it up, right? There is a screen, input coming from different sides, and you're looking at the responses. Then the machines seem to be able to do pretty much anything, you know, that humans are doing. So artificial intelligence clearly has expanded, and today it's everywhere, right? In all our day-to-day lives, all these different apps, tools, you know, are using artificial intelligence under the hood for various purposes, right? So for customer profiling, Facebook, we all know what they do. Sentiment analysis, you know, Twitter, you know, they're analyzing, saying, you know, which political side is which tweet, and, you know, is it left or right leaning, and so on. So those are done. LinkedIn is using it for various talent search companies. So all these are using artificial intelligence. So where I'm leading this is, do you see any of these apps, and these are just some examples, that you would call social good? I think most people, if you do a survey, they'll say this is all social bad, right? Because this is mostly about companies making money. It is about some efficiency, but the target seems to be, you know, about driving market and, you know, advertising and, you know, making more money for different companies. So I wouldn't call it social good, although somebody can say, well, it is creating jobs and that's all about social good. Well, you know, we understand, you know, what is the primary focus of these different applications? It's about efficiency, marketing, and making money. So then what exactly is social good? We will look at that in a second. I just want to point out also over here, and this is taken from IEEE Spectrum, as to why AI, after the initial hype, you know, while all these apps are working beautifully, I mean, we are all amazed as to how Google Maps, even in India, you know, with all the small lanes and different roads and everything, it can figure out where you are and, you know, how the lay of the land is. But in a very broad sense, you know, when you compare it with human intelligence, then we have to say that AI is failing. And this article talks about 7 different ways in which it is failing. So they talk about brittleness, that these programs are very brittle. Apparently there was a survey done and the machine was shown a bus that had tipped over. And none of the programs could tell that it was a bus. Whereas any kid who has looked at 2 buses would say, Papa, Papa, the bus just tipped over, right? So these AI algorithms are very brittle. We all know they are biased, right? Because, you know, when you look at the justice system, when the way the banks are giving loans, you know, is it all fair? The way the justice system is looking at, you know, punishment for various different crimes among different sections of society, if AI is being used, is it fair? And we all find out that it is biased based on the data that was used to generate those algorithms. Explainability, you know, we all talk about this, saying, for example, when we were doing the postal address problem, it was very important for us, for the postal system, to not give an answer when you are not sure. Because if you give an answer and you generate that 11-digit barcode, the mail piece will actually travel all the way to some location, and then if it is the wrong address, it has to come back and send some human being. So you have actually multiplied the cost. So what we were told was, whenever you give an answer, you have to be absolutely sure that it is correct. If you have any doubt on the answer, don't give the answer. We'll send it to human reading right away. It's almost like negative marking in multiple choice questions, right? Don't guess, if unless you're very, very sure, don't choose an answer, because it will give you negative marking over there. So that is an ability which we want in our systems, and most of these today's deep learning, and I'm sure progress has been made. But if I make a general statement, many of the deep learning algorithms of today are unable to do that. They are just as sure about the right answer as they are with the wrong answer. So explainability, why the answer has been given, the way it has been given, is also an important part. Common sense, whether it can have common sense and not being explicitly programmed every time. Quantifying uncertainty, forgetfulness. This is an interesting one. What it means is that every time you have a new application, you have to relearn. It's almost like saying, every time I have to read a book, I have to start learning the alphabet one more time, right? So there is no carryover intelligence, and whenever there is carryover, you start forgetting. It's like if I read the second book, I've already forgotten what I read. This happened to me while I was in school, many of us, right? You're reading and reading chapters 2, 3, 4, now you've forgotten chapter 1, chapter 2, then you go back. So there is a lot of forgetfulness in these systems also. And also when we talk about math, the calculator, that we use in our engineering, projects, they're always correct, right? But if you want to use a deep learning kind of approach, to solving math problems, and they did some tests, apparently it was not even 5%, accurate. So a whole bunch of issues are there, but what needs to be highlighted among those 7, the most, is the one of bias. Right? The bias isn't the only problem with credit scores, and no, AI can't help. This is headlines from artificial intelligence. LAPD will end controversial program that aims to predict where crimes would occur. You can see many facial recognition systems, and I'm sure many of us have noticed that Facebook a few years back was making boxes on my own pictures on my own page and asking me to verify whether it is the right person or not. And it was doing a whole bunch of face recognition, and that has all been withdrawn, right? Because there is lots of bias, in many of these programs. And also I believe certain cities like San Francisco would not even allow face recognition, with public cameras. So all because of the bias, and some also for privacy reasons, but mostly because of bias. Amazon scraps secret AI recruiting tool that showed bias against women. So what I've been trying to say over here is, there is AI. What is the difference between artificial intelligence, human intelligence, the issues with the AI applications, and then the second part of the title today is AI for social good. So I said these are not for social good. This could not be. This is just another way of making money for these companies. So what exactly is social good? Well, what if artificial intelligence could predict natural disasters before they happen? Would you agree that that would be a noble cause? Track disease as it spreads to eliminate it sooner. While companies may make, and I'm sure they should make profits, but what is driving the project, immediately we can tell is for social good. Dramatically improve the lives of people with disabilities. Social good. In fact, we all talk about interdisciplinary research, right? I'm sure in India, for all these government projects, that's a big deal. In the US, you cannot get funding of any significance, unless you have an interdisciplinary team and a project like that. So here is a nice metaphor. Let me see if you can relate to this. When we talk about fruit salads, right? So in order to make a fruit salad, you need very delicious fruits, and you slice and dice them, you put it in a bowl, and it's like a fruit salad. So each fruit is like a discipline. So mango is one discipline, and banana is another, apple is another, and so on. And all fruits need to be delicious in order for the fruit salad to be delicious. So this is like interdisciplinary research. All disciplines, you need to be deep and strong. You come together, and that's interdisciplinary research. You get a fruit salad. In the interdisciplinary research, you can still identify the different fruits, right? In the salad, you can say which pieces you're getting. Now the next stage, and the stage that we are looking at, is what is called convergence, or what I'm going to call social good now, is that it is like a smoothie, right? You take all delicious fruits and you put it in a mixer and you have a nice shake, okay? Here you cannot identify the different disciplines. You cannot say, here is the piece of apple and here is the piece from banana. It's all blended in to give you a nice smoothie. So the convergence approach today in the US, and National Science Foundation is driving it, is that you first choose a problem, a societal problem. And problems in society don't come in silos, right? Nicely packaged, saying this is a problem for mechanical engineers and here is a problem for civil engineers. It doesn't do that. There are societal problems, and you take all different approaches to solve that problem. This is the smoothie or the convergence approach. Strong disciplines all coming together and blending in such a way that you cannot tell how the solution is taking different pieces and arriving at the final goal. So here what we are doing is we pick a societal problem. Let us say we say natural disasters before they happen. Now let all different disciplines come together, whether it is civil, mechanical, computer science, data science, whoever, right, social people, urban planning, all come together and solve this problem. And there now the driving force is social good, okay? So looking back, I can say, well, the postal project was also social good, isn't it? Because you made things efficient and the postage rate did not go up and it helps society. Yeah, but that was not driving it, right? The profits was driving that. So, for example, today the pandemic has had devastating impacts on learning. What will it take to help students catch up? If this is the problem I'm trying to solve, then I will have a different way of approaching the problem than if I said, oh my God, from the pandemic we realized that we can actually have hybrid classes. How can the university save more money? Or how can we do this? It's all driven by efficiency and profits and tuition, and that's not what I call social good. The social good would be, you start by saying, during the pandemic we realized that many students were not able to actually get the full benefit of education because they didn't have proper connectivity, because they could not do X, Y, and Z, and how can we address that problem? That will be social good. So another way of doing this is look at what United Nations has called, the sustainable goals for development. And they have given out 17 different topics here. One is called no poverty, another is called zero hunger, one is called quality education, and so on. So if you can choose one of these, and once again take that convergence approach. So I want to solve the problem of hunger, okay? Noble, social good. Okay, so what will it take? Well, should I consult agriculture engineers? Should I consult data science people? Should I consult, the social, NGOs? Who are the people who can contribute? And let them all come together to solve that problem, okay? So I'm going to give you, for the rest of my talk, 3 or 4 different examples of how we have chosen a few of these 17 noble goals and tried to come up with some solutions. So the first one is about quality education. And so the United Nations is talking about virtualized intelligent mentors and responsive personalized learning is revolutionizing education and improving participation and outcomes, all powered by AI. Online providers such as Coursera have AI produce granular information for effective learning. Big data analysis is improving graduation rates of low-income and first-generation college students by 30%, spotting warning signs before dropout to allow targeted interventions. So you can see there is a social good that is going to drive everything. Okay, so let me share with you some what we are doing in our lab. So we said, in order to provide access, to material, and this is not just for pandemic and hybrid and virtual learning, but in general, for students to learn better, we should be able to index and search the video lectures, in a much more efficient way, right? It cannot be just that this particular video is tagged as, differential calculus chapter 2, so that's not how you want to do it. We want it to be a much more richer interaction where, I can query different pieces of a graph or a chart or equations, chemical equations, from a whole 1 hour video lecture, and, let students look at, that particular snippet, something before it, something after it, so it can be a much richer experience. So towards that end, we said, let us say you are going to allow complex querying. So my query is on the left side top, you can see there is an equation, okay. So I sub n is equal to I sub n a and so on. And suppose I want to find out where in the video lecture, in the one lecture or all the lectures during the semester, where did that appear? So I want to go fast forward to that portion of the video, look, around that and, gain whatever I need to gain, okay. And you can see how important and useful this is going to be because, you can have hours and hours of lectures, right. So how do you search? So we should be able to find connected components in video lectures. We should be able to identify mathematical expressions. We should be also able to remove the occlusion of the person, the lecturer who's writing on the whiteboard, right? Because it could be hiding. And how do you decide when you have a full frame? When is the board full? I mean, there are very interesting problems over here that need to be solved in order to provide that kind of querying ability. So what we would do is, we want to generate automatically what you see on the right side. In the lecturer's handwriting, from the whiteboard, we are able to pick up the notes. We have subtracted out or removed the lecturer from the frame, and we have decided how many video frames do we need in order to come up with 1 page of notes for that, right? So now when you query, I will give you the spot in the video and I will also give you the notes that go with it. And so all these, by the way, have been published. Some of them won some best paper awards and so on. So what are the sub-problems here? Detector bounding boxes are, so you detect the bounding boxes and you remove the occlusion and you generate the notes. What else? Well, we should be able to tell, because I want to take the lecture notes at appropriate times, I should be able to tell when is the lecturer writing, when is the lecturer erasing what is being written already and write again, and when is the lecturer turning around and explaining, right? I should be able to figure all these things automatically from a video lecture. So then the problem is pose estimation of the speaker. So we should be able to tell, and perhaps based on which way the person is looking at, how the hands are and what is happening, I should be able to tell writing, erasing, explaining, side profile, front profile, back profile. So we are able to do these, and then we can tell which mode is the lecturer in, and from multiple different tracks or views. Okay, so these are just some results from some different competitions. Let me just show a video of the whole application, to make the point. So you can see the query is pi e and parenthesis. So it has to go and see in the notes which have been automatically generated. So it is matching the elements, you can see. Then it will navigate the search results. So it is telling you where in that video hour that particular pi e came up. It showed you that. This is the next place where it showed, and so on. I think this is a longer video, so you get the point, right? And this would be very useful. Next, another social good objective is good health and well-being. Suppose that's the one that I want to look at and converge from all sides, from different disciplines and expertise to solve that one problem. So preventative healthcare programs and diagnostics are significantly improved through AI, leading to new scientific breakthroughs. So I'll show you what we did in this regard. So what we did was, we said, let us look at facial expressions. Can AI help in better understanding non-verbal communication? That is like the expression of a face. So I don't speak anything, just based on my expressions, can you communicate? Can AI facilitate mental health? And mental health is a big issue on our campuses, I'm sure in India as well, where, and given all the social media network and the pressures that come with it, where our younger generation is depressed, right? And they're having all kinds of mental health issues. How can you spot that ahead of time? How can you identify based on facial expressions in the class, right? So there are two things. One is the student engaged? It's not just attentive. Can you tell whether the student is following just based on the facial expressions? Can you tell if a person is in pain? So these are very interesting, because also because of the stigma, students may not come forward and talk about these things. Can you do these things automatically? Can AI help in developing tools to assess levels of engagement? So we looked at examples such as these, where based on how the expression is, so we will check out the brows, the lips, we will look at the eyes, how they're closing, the cheek, and the wrinkles in the nose, and we will tell you whether the person is in pain and what level of pain. And is it transient or is it staying on? Okay, so you can see computer vision, image processing, video analysis is coming together, but it's about social good. It's about helping the well-being of our students. And in this regard, also about engagement. How can you tell if a student is actually following the class? Maybe they need additional assistance. Maybe they need some additional coaching after class. How can you tell? Because once again, students are sometimes shy to come forward. They are embarrassed to say that, to raise their hand and say, can you please go over it one more time and one more time? So how can you tell just based on today, given that lectures are all captured on video, can you tell the level of engagement? So we have looked at, by the way, facial expressions and action units, so there are a whole bunch of ways in which the face can move. And as I said, eyes, nose, mouth, wrinkles, and so on. And can you tell whether the person is angry or disgusted or happy? So those are the kinds of things that we have looked at, and these are called action units. I will come back to this lower example over here in a little bit. I'll come back to that, but please note how on the right side the person is nicely smiling, and on the left side only half the face is smiling because one half is paralyzed. I'll talk about it in a minute. So these are the different action units, so we do video analysis to tell, which part of the face is moving, and based on that, we look at different action units of the face, and we will tell you what that expression is. And this is not non-trivial, by the way, because when action units combine, it is not a simple addition. So action unit 1 and 4 can combine and come up with something totally different, right? So if you have inner eyebrow and brow lowerer, they both come together and a new expression is created. So looking at face and doing this kind of analysis and looking at different expressions by the same person and different people, same expression, we have a whole bunch of graph analysis on the face that we are able to do. And then, for the biometrics applications, each action unit can also be a signature. So I know Mayank, your group works on looking through makeup and disguise and so on. So even if I am disguised, let's say I have grown a beard and, and painted my face, but these action units you cannot hide, right? So when I smile, when I'm angry, the way the different parts of my face will move, those cannot be disguised. And if your signature is based on those action units, then you have something unique that can be looked at. So we actually also used the facial expression analysis for deception detection. So the picture, if you remember, the previous picture I showed of the person paralyzed here. So what was happening was this person had a tumor in the brain. When the person was asked to smile, or there was not asked to smile, when the person had a genuine reason to laugh and smile, the whole face would light up like a normal person. But if you ask the person forcibly to force a smile, only half the face would smile. So what that tells is that there are different parts of the brain which work on natural expressions and which work on forced expressions. The forced expressions are part of deception. So if I'm saying one thing and my expressions are conveying something different, there is a mismatch, and that is deception. So I could say, no, I am not angry, but anger is oozing out of my face. And we know how that happens in our households, right? So we can tell that there is a mismatch. So we use that, in order to do deception detection as well. And we used actually data sets from something like the Big Boss TV show over here, where you have people acting and later on you say whether they were, what they were doing. So we used a similar show called Big Brother, to create our data set on that. The third social good application I want to talk about is no poverty. Guess, we are computer vision pattern recognition people, and I'm saying the problem I want to solve is eradication of poverty. So here, AI will provide real-time resource allocation through satellite mapping and data analysis of poverty. So what we did was, one of my students actually traveled to Africa, Senegal, and to help out with, poverty mapping of that country. Because all the government resources, as you know, they want to send it based on, what the income levels are and, in different sections of that place. And it's very inefficient. And the parameters that they use for poverty are things like education level, how many years of schooling does that section of population have, what is the enrollment rate, what is the malnutrition rate, what is the child mortality rate, do they have cooking fuel, what kind of sanitation, drinking water. So there are 10 different such parameters which are tracked to tell how poor that particular geographical region, people in that region are. And without AI, this has been very inefficient because it is being done manually based on surveys. You go and survey a few people and you ask, and it's okay, but it is not very accurate, right? So you can do much better. So what we did was we looked at data coming from mobile phones, satellite imagery, weather data, OpenStreetMaps, all different sources, because everybody has a cell phone today, right? No matter what the poverty level is, everybody has a cell phone. So you can look at data and then you can decide, the poverty level based on those indices. So on the left side, you see based on surveys. On the right side, the fine granularity is based on our data fusion approach. This is what artificial intelligence can do, so that you can see right away that there will be a tremendous savings, in resources, so that there is no wastage because of the fine granularity, and you can pinpoint exactly what help is needed in which area for what section of society. So this is also something we did, and by the way, that was published in the Proceedings of the National Academy of Sciences, a very prestigious place. Now, another social good problem we are looking at is zero hunger. Again, somebody might ask, are you really talking, are you a computer vision person, pattern recognition? What do you do? What do you have to do with zero hunger? Well, agricultural productivity is increased through predicative analysis from imaging with automated drones and from satellites. Nearly 50% of crops are lost through waste, overconsumption, and so on. So you can see with new data and with new techniques and artificial intelligence, we can actually address these problems. So what we did, and by the way, at Buffalo, we are leading the way. We have connections with the United Nations, and we have a project with the Food and Agricultural Organization of the UN. So as you can see, a quote from my colleague here. To my knowledge, this is one of the earliest documents outlining how local governments can take action to create innovative and equitable food systems for low and middle income countries. So there are 690 million people who go hungry in the world. And even in a rich country like the US, there is food insecurity, because it's also a question of distribution, and all kinds of issues are there, and people can still go hungry. So what we did was, there are various food camps, and in order to manage these food camps, so certain camps have certain vegetables and certain bread and all, whatever the food items are. How do you coordinate between all these camps so that a person who is hungry knows in real time on their phone which camp to go to get the food that they want? So what we did was, and here is the computer vision interesting part. So we look at food shelters like these, and the person who is running the shelter will take an image on the phone or something, and then we have AI algorithms which will tell how many apples are there in the basket. Or if there is a board with handwritten text with prices, it will read and tell, okay, at this place bananas are for 10 cents and pears are for 5 cents, and we have 40 pears left, right? It's all done in real time and managed so that people who are hungry at different times of the day know exactly where to go and what they can get. So once again, social good. So computer vision. So instead of talking about the chart on the right, saying what kind of neural network we are using and deep learning and so on, we are talking about the actual application. Our focus is on social good. And to conclude here, the last piece that I'm talking about is education for all, democratization of education. How can we make education accessible to all sections of society, including and particularly to those with disabilities? Because there are people like 33%, of the disabilities are for learning, different learning types, and speech and language impairment. How can we help kids in our classrooms, who are struggling with different disabilities, and what can AI do? How robots can assist students with disabilities. This is a problem we are looking at. Another problem, again, you can see there is no money angle in this. Nobody is going to, this is for social good. How can we make historical documents, available to the general public, just so that they are better informed? Okay, so that our libraries, our digital libraries, are giving access to these documents. So we have worked on enhancing different documents. On the right side, you see, handwritten notes, historical. This is from Marion Moore, a poet, American poet. How do you, make them accessible, indexable at a deeper level? So we are looking at that. Okay, so let me conclude by saying that artificial intelligence, for social good, happens when you look at the problem first and come and try to come up with solutions from all different angles. And when we are doing this, we always keep in mind that we are being responsible. People talk about responsible AI, ethical AI, inclusive AI, trust. I saw Mayank's lab is called Trusted AI. So all these are different aspects of AI, but when we talk about social good, that has to take center place. Let me conclude with that. AI for social good. In fact, our own Indian texts talk about loka samasta sukhino bhavantu. So this social good piece has been there with us for ages, and with that I conclude my talk. Thank you very much for paying attention, and look forward to having some questions.
Hello. Here, can I ask you a question? Thank you. That was a wonderful talk, and I'm not from this area, but I just wanted to ask a very fundamental thought is that if you say AI for social good, what is an economic driver for that? Meaning, how do you sustain it unless there is a financial driver? So how do you manage that? Meaning you can get grants and you can implement something, but then to keep it running for social good, how would you visualize it? I'm not able to visualize it, and especially in a country like India, if you want to implement that, the first thing would be that what do you do with the people who are low skill and want to do that? Then how do you upskill them? Meaning these are the two questions I just thought I would ask you.
Now, good question. See, when we are trying to address something about social good, the different pieces that will go there in order to address that problem can be reused for all your financial and efficiency reasons, right? So the computer vision algorithm that we are developing to help count the number of apples in a basket, right? I'm sure that same thing can be used by the supermarket to make things more efficient in the supermarket. When do you order, the supply chain and so on, and they can save money over there. So in any of these tasks that you pick up, so when I talked about video lectures and I said, okay, let it be for social good so that people during the pandemic, how they can access, the same tools and techniques can be reused, repurposed for other, the traditional economic driven, projects. So I think so it will sustain. So the government can focus on solving the big societal problems, and all the pieces in that whole ecosystem that comes about to solve it can be repurposed, and they would be done anyways. Society will drive it over there because people want to make profits and be more efficient. So that will happen anyways. The second part is about upskilling and
Implemented in
Right.
India, meaning the US ecosystem and Indian ecosystem is very different. So what are your thoughts on this at the ground level in India?
Yeah, so the way I envision this is, if the government can set up right now, I remember, so government would say like Ministry of Information Technology, do OCR for different languages in India and so on, right? So they can drive things. If they come up with, like the United Nations, big grand challenges for Indian society, right? and let different labs, in the country work towards that, then it will be natural, because none of these problems can be done by one PhD student, right? You will need hundreds of PhD students to work on these. And those students will then go and, use those techniques that they have picked up, to go and do other things. So I don't see a contradiction or a conflict over there. And it also gives you a higher level of satisfaction that you are part of a, bigger social good kind of thing.
Yeah, so one of the very recent criticisms for the deep learning models is the amount of energy they use in order to produce those models, and it's actually affecting the environment. So you did talk about earlier models that you were using, which were using very few examples and probabilistic, and they were good. So my question is, are you using similar models as earlier now, or how are these challenges likely to be addressed in future?
Yeah. Well, first of all, a capitalistic society is driven by profits and money making and so on. So those are the natural forces in play. What has happened today, people can comment on this, is that in order for us to publish our research, right? I mean, unless it is published, it might as well not have ever been done. In order to publish research, you have to meet certain benchmarks. And all the benchmarks set today, are favoring the big deep learning, big data kind of approaches. So as long as that is there, it is very difficult to go back and revive some of those old methods. So it has to happen in a more natural way, something else other than the energy consumption, which is a big deal. Something else also has to happen for that to shift back, into what I would say, a more human-like intelligence approach, a more humane approach, if you will. So, yeah, I think, as long as conferences, program chairs, and there are many program chairs here sitting, who are accepting papers based on whether you meet or beat the previous benchmark, nobody is going to work on methods which don't perform well. But I think it will come around, it will just take a few years. Already people are talking about the hype of AI, right? They already, 2 years back, if you looked at popular science articles on autonomous driving vehicles, there was so much of optimism in that whole area. Haven't you seen that has died down pretty much? So now the expectations are, much more narrower today. So I think that some of those things, are going to make a comeback, those earlier methods.
Yeah, thank you, sir, for a wonderful lecture. It's Jayant here. Yeah, so sir, I have seen your work on the stress recognition of the human. So we are also working on the driver stress recognition, driving induced stress. So you are working using the, recognizing it using pictures or images or facial expressions. And we are also doing the same using physiological data collected in either simulation or the naturalistic driving environment. So what is your opinion that which one is the better one? Like using facial expression or physiological data?
Actually, there is no such thing as something is better than the other, depending on what you're measuring and what the application context is. One approach can be better than the other. But if you're allowed in your application, then it's best to use all approaches and combine them, right? So physiological might be too intrusive in certain applications, so maybe you won't be able to get the kind of data you want. But if you are able to get it, then use everything that you can.
Thank you, sir.
So I would like to thank Dr. Venu for very inspiring talk. Thank you, Dr. Venu, for delivering this talk.
Thank
Now I would like to request Dr. Chaudhary to come on stage and give a memento to Dr. Venu.
Oh, thank you. Thank you, Chandra.
Thank you, Dr. Chaudhary. Now I'd like to request Dr. Vadera, the Deputy Director IIT Jodhpur and Chairman of Institute Lecture Committee, to give vote of thanks. Dr. Vadera, please.
Good evening to all. It has been really a very wonderful lecture. AI for society, social cause. This is really a subject, AI is really a complex subject, at least for me. But then when you see the things around you, everywhere you find AI. And this is something very interesting to see, that how it can be good for the society and how you can use it for the society. And he has put in a lot of examples, maybe education, hunger, poverty, all these things. AI is artificial intelligence. I talk another AI also. And if you can have, both the AIs integrated, it can be really wonderful. The another AI is your attitude and intention. So if this artificial intelligence is coupled with a positive attitude and right intention, then really it can be a wonderful thing. We profusely thank Professor Venu for sparing his valuable time and coming up for this lecture at very short notice, just 2 days notice, and then he agreed to give this lecture. And I think this will go a long way for us, and particularly for youngsters, that how such kind of technologies can be used for the benefit of the society. I would like to thank Dr. Richa and Mayank for making this lecture possible. Also, I would like to thank the team which has put efforts to organize this lecture at such a short notice. I think all of us have got benefit and inspired by this lecture. Particularly, he has talked about sustainable goals and sustainability of the society. That is what is very important. And I think all of us should imbibe those things and can make use of not only AI, but whatever technologies we are working on, how we can use it for social cause. That is the kind of message, if we can carry with us, that will be really wonderful and useful for us and useful for the society. So once again, we express our sincere thanks and gratitude to you for being with us, and thanks to all the people who really participated in this particular event. Thank you. Jai Hind.
Thank you, Dr. Vadera. Now I request everyone to join for tea arranged outside the lobby area. The guests and faculty members